Hello everyone. So this is video number 4 on chapter electricity. In the last video we learned about the statement of Ohm's law. Okay. So this is nothing but the statement. Ohm's law is nothing but the relationship between the potential difference and electric current flowing through the conductor. Statement says that the potential difference applied between the two ends of a conductor is directly proportional to the amount of electric current flowing through it, provided temperature remains constant. That means V is directly proportional to I. I told you that voltage is nothing but the work done to move the unit quantity of charge, and electric current is nothing but amount of charge flowing in a unit time. Both the quantities having quantity of charge, that means these two quantities must have a relation between them, and that relation is nothing but given by Ohm's law. I also shared a link with you about the activity, a video that explains the activity practical about this Ohm's law. On the basis of that particular practical, if you take a certain values to verify this Ohm's law, so what we can conclude from that particular values? Let's see. So with respect to that practical given there in the video, for example, if you take some random readings, some other readings were there in the video, we'll take some other readings. Okay, for example, first reading is about the number of cells. Another reading, the voltage provided by that cell. Next one is amount of current. It is number of cell, voltage provided by that cell, amount of electric current. So this is nothing but RV, this is nothing but I. Here we'll get the ratio, okay, and the answer for that ratio. That is nothing but our constant, because Ohm's law says that V is directly proportional to I. That means V by I is always remains constant. Is it clear? So for example, first we connect one cell, okay, that provides the voltage of 2 volt. When we provide the voltage of 2 volt to the particular circuit, then in that particular circuit, ammeter gives us the reading that 1 ampere of current is flowing. Okay. Now we increase the number of cells. Another identical cell we are going to use. Now this time we use 2 cells, each of 2 volt. पहले एक ही थी, it is of 2 volt. Now we are utilizing 2 cells, again each of 2 volt. So it becomes 4 volt now, 2 plus 2. Now the amount of current flowing through that particular circuit, the ammeter gives us the reading, for example 2 ampere. Okay. Next reading, now we are connecting 3 cells, 2 volt each. It provides the voltage of 6 volt. Now the current is of 3 ampere. Now see the statement. Number of cells goes on increasing. Voltage goes on increasing. As voltage increases, amount of current also increases. So we can say that V is directly proportional to I. Now take the ratio of them. 2 by 1. Voltage is 2 volt. Current is 1 ampere. 4 volt, 2 ampere, and 6 volt, 3 ampere. So your answer must be in each case 2, 2, 2. And what is that 2? This constant number 2 is called as resistance. So we can say that V by I is always constant, that is nothing but the R called as resistance. So this is nothing but the activity to explain Ohm's law, that voltage goes on increasing, amount of current also increases, but that increases in a direct proportion, that every time you will get the same answer for the ratio V by I, that is nothing but constant called as resistance. Now we are going to learn that what is exactly the meaning of resistance. Now this is all about the activity which is there in the video also. Now see what is mean by this resistance R. Okay, resistance is nothing but, I am going to write down here what is mean by resistance. If you want to define this particular term resistance, that resistance is nothing but tendency, the tendency of every material, tendency of every material to resist or oppose the flow of current through it. Resistance is nothing but the tendency of every material to resist, or we can say oppose, the flow of current through it. That means every conductor, whether it is copper, whether it is aluminium, whether it is silver, okay, these all are the conductors, they are good conductor of electricity. But this every conductor having ability to oppose the flow of current through it. Means if this is the copper conductor and when the current is going to flow through it, this particular material first oppose that particular current. It does not allow current to flow easily. Okay, now think about it. Means if any material opposes with the greater energy, that is bad conductor. And if any conductor allows current to go easily, that is good conductor. जो अपोज ज़्यादा करता है करंट को जाने के लिए, दैट इज बैड कंडक्टर. और जो अपोज बहुत कम करता है, आसानी से करंट जाने देता है, दैट बिकम्स गुड कंडक्टर. सो हु इज गोइंग टू डिसाइड वेदर द गिवन कंडक्टर इज गुड कंडक्टर और बैड कंडक्टर? इट्स एबिलिटी टू अपोज द फ्लो ऑफ चार्ज. अपोज कम, it becomes good conductor. Oppose ज़्यादा, it becomes bad conductor. So who is going to decide whether the material is good or bad conductor? It is nothing but its property called as resistance. Okay. So with respect to formula, number of cells are going to connect to the circuit. First cell 2 volt, 1 ampere, 4 volt, 2 ampere, 6 volt, 3 ampere. So the ratio 2 by 1, 2, 4 by 2, 2, 6 by 3, 2. So with respect to the formula, V by I is equals to R. Actually, you must have to write down the formula in this way. Therefore, V by R is equals to I. So mathematically तो same ही है, but उसका meaning क्या होगा? Okay, just listen. By connecting the number of cells, we can change the potential difference. Yes, by connecting the number of cells, we can change the potential difference. And wires are already connected to that particular circuit. Wires completes the circuit. Yes or no? So आप number of cells को change करके voltage change कर सकते हो. But the resistance of that particular conductor decides, वो wire की ability decide करेगी that if you provides with a voltage of 2 volt, if you provides the potential difference of 2 volt, and the conductor, the copper wire, having the ability to oppose the flow of charge, and that ability is nothing but the resistance. And what is the value of that resistance for that particular conductor, which is always remains constant? हमारा आंसर है उस एक्टिविटी के लिए 2. तो ये 2 डिसाइड करेगा. If you provide me voltage of 2 volt, my ability to oppose the flow of charge is 2. तो मैं मेरे अंदर से कितने करंट को फ्लो होने दूंगा? 1 एम्पियर. सो कौन करंट की क्वांटिटी डिसाइड कर रहा है? रेजिस्टेंस. और ये रेजिस्टेंस हमें किस पर्टिकुलर लॉ के कारण मिला? ओहम्स लॉ. दैट्स व्हाई दिस पर्टिकुलर रेजिस्टेंस इज मेजर्ड इन द SI यूनिट कॉल्ड एज ओहम. This is our new quantity resistance denoted by R and its SI unit is this particular sign called as ohm. So अगर मैं एक बैटरी जोड़ता हूं that provides me the voltage of 2 volt, okay, and that particular conductor having a ability to resist the flow of charge or flow of current through it is of 2 ohm. So 2 volt अगर आप मुझे provide करते हो, and what is meant by voltage? Voltage is nothing but the work done to move the unit quantity of charge. Yes or no? So 2 वोल्ट का अगर मैं पोटेंशियल डिफरेंस अप्लाई करता हूँ, मतलब मैं 2 वोल्ट का वर्क डन कर रहा हूँ, तो वो वायर मुझे बता रहा है माय एबिलिटी, माय रेजिस्टेंस इज ऑफ 2 ओम. मैं 2 ओम का रेजिस्टेंस आपको अप्लाई करूंगा. सो व्हेन 2 वोल्टेज ऑफ पोटेंशियल डिफरेंस इज प्रोवाइड, 2 ओम ऑफ रेजिस्टेंस डिसाइड्स दैट 1 एम्पियर ऑफ करंट इज गोइंग टू फ्लो थ्रू दैट पर्टिकुलर कंडक्टर. फिर आपने क्या किया? वर्क डन बढ़ाया by applying more number of cells. Now the voltage is of 4 volt. वायर अभी भी वही है, अगेन द सेम रेजिस्टेंस 2 ओम. अब इसने कहा कि आप मुझे 4 वोल्ट दोगे. नाउ द करंट इज ऑफ 2 एम्पियर. अब अगर आप मुझे 6 वोल्ट दोगे, नाउ द करंट इज ऑफ 3 ओम. सो हु इज गोइंग टू डिसाइड the amount of current flowing through the conductor? It's resistance. If you applied the voltage, the resistance of that conductor, which is nothing but the ability to oppose the flow of charge, decides what amount of current flows through it. If any conductor opposes more, less amount of current will flow. If any material opposes less, more amount of current will be flow. Is it clear to all? Just see 6 volt, 2 ohm resistance, 3 ampere of current. अगर आप यहाँ पे रेजिस्टेंस बढ़ा दो तो देखो 6 वोल्ट सेम वोल्टेज, रेजिस्टेंस बढ़ाओ 2 ओम है, चलो 3 ओम कर दो. व्हाट विल बी द करंट? 2 एम्पियर. अपोज करना कितना है? 2 ओम, सो करंट विल बी 3 एम्पियर. Now here the opposition is 3 ohm, so current will be 2 ampere. So if you increase the resistance, amount of current will be less, because resistance is nothing but the tendency of every material to resist or oppose the flow of current through it. Is it clear what is meant by resistance? फिर भी अगर नहीं समझ में आया, so I will give you another example in your real life. Okay. For example, you can relate with this. See, as a teacher, we are teaching to the near about 40 students sitting in a classroom. Yes or no? For example, I am going to teach this Ohm's law in your classroom to the 40 students. Okay. Now, whatever the knowledge I am having about the Ohm's law, I am going to try to deliver that particular knowledge towards the students. यस और नो? मेरे पास नॉलेज का हाई प्रेशर है, आपके पास नॉलेज का लो प्रेशर है, सो दैट नॉलेज विल फ्लो फ्रॉम हाई प्रेशर टू लो प्रेशर. अब मैं सब लोगों को एग्जैक्टली इक्वल पढ़ाऊंगा, बट योर एबिलिटी दैट इज नथिंग बट दी योर रेजिस्टेंस. आप अगर कंडक्टर हो और मैं अगर बैटरी हूँ जो चाहता है कि आपके अंदर से नॉलेज फ्लो हो, सो आई एम गोइंग टू अप्लाई द फोर्स, बट यू आर द कंडक्टर्स. आप लोग डिसाइड करोगे कि व्हाट अमाउंट ऑफ करंट फ्लोज थ्रू इट. करंट मतलब व्हाट? नॉलेज. कोई बहुत स्मार्ट बच्चा होगा जिसको साइंस में इंटरेस्ट है, जिसे साइंस पढ़ना पसंद है, ठीक है, तो उसे जल्दी से समझ में आएगा, तो वो उस साइंस को कम रेजिस्ट करेगा. क्या रेजिस्ट करेगा? कम रेजिस्ट करेगा, तो उसे जल्दी से समझ में आएगा. सो दैट बिकम्स गुड कंडक्टर ऑफ साइंस. आ रहा है समझ में? लेकिन कोई बच्चा होगा जिसे साइंस में इंटरेस्ट नहीं है, वो साइंस पढ़ना नहीं चाहता है, उसकी मजबूरी है, यस और नो, तो वो क्या करेगा, मुझे रेजिस्ट करेगा, सर आप कितना भी पढ़ाओ मुझे नहीं पढ़ना, आई एम गोइंग टू रेजिस्ट। सो वो उस साइंस के लिए कौन हुआ, बैड कंडक्टर। सो जो ज़्यादा रेजिस्ट करेगा उसे कम समझ में आएगा, ज़्यादा रेजिस्ट करेगा कम समझ में आएगा, कम रेजिस्ट करेगा ज़्यादा समझ में आएगा। और ये हर एक स्टूडेंट की एबिलिटी है, हर एक कंडक्टर की एबिलिटी है। तो टीचर चाहे कितना भी पढ़ा ले, कितने भी आप बैटरीज लगा लो, बट हु इज गोइंग टू डिसाइड द अमाउंट ऑफ करंट, रेजिस्टेंस ऑफ दैट कंडक्टर। सो V and I does not decides R. You provided voltage by connecting the batteries. The resistance of that wire decides what amount of current will flow. Is it clear to all? That is nothing but your resistance, the tendency of every material to resist, or we can say oppose the flow of current through it. So this is nothing but your new quantity called as resistance, which is given by Ohm's law. Hope you understand. Okay, so we'll get the new quantity from this particular law called as Ohm's law, which is the most important topic from this chapter. Ohm's law. So our new physical quantity resistance. So क्या काम है रेजिस्टेंस? Resistance is nothing but the ability or tendency of each and every material to resist or to oppose the flow of charge through it. The object which is having less resistance allow more current to flow through it, and the material which is having high resistance allow very less amount of current flows through it. So we'll get the formula for R. That resistance R is V by I. Ohm's law tells us that V is directly proportional to I. According to that, V by I is always remains constant R. That's why अगर आपने वीडियो देखा होगा तो उस वीडियो में you will get the particular readings and you can plot the graph on the basis of that. If you provide V here, I here, okay, so voltage goes on increasing, amount of current will also increase, and you will always get the straight line that indicates V is directly proportional to I. Okay, so V by I is equals to R, which is the constant value for the conductor. Is it clear to all? So R is equals to V by I. Then what is the SI unit of this resistance? SI unit of resistance is Ohm, because it is given by the scientist Ohm. Okay, so having the symbol like this. Okay, then so when we can say that any conductor having a resistance of 1 ohm, so we can say when 1 volt of potential difference is applied, when 1 volt of potential difference is applied between the two ends of a conductor, and it allows 1 ampere of current flows through it, then the resistance of that particular conductor is of 1 ohm. Is it clear to all? So new quantity resistance R is equals to V by I. SI unit is ohm. So when we can say that the conductor having a resistance of 1 ohm, 1 volt of potential difference is applied between the two ends of a conductor, which allows 1 ampere of current to flow through it, then that conductor having a resistance of 1 ohm. So R is going to decide the amount of I when V is provided. Clear to all? Yes or no? Okay. So this is all about your new quantity called as resistance. Okay, so up to this particular portion from the chapter electricity, I am going to recapitulate all the topics that we have learned in previous videos. Okay, we learn about electric current, its formula, its SI unit, conventional direction of electric current. Yes, then we learn about charge on a single electron, charge of 1 coulomb contained by 6 into 10 to the power 18 electrons. We learn about potential difference, its definition, its formula, and who provides the potential difference, that is battery. Okay, now the relation between the potential difference and electric current, which is given by the Ohm's law. Then Ohm's law gives us the new physical quantity, that is resistance, that we just learned in this particular video. Is it clear to all? So for today it is about the resistance. Okay, thank you so much.